I explain how to use GeoGebra to compute the limit of a function. If the function is a continuous function, so a function in which you can compute the limit as the image of a number, so the limit as x approaches to a of the function is equal to the function evaluated in this a. So the only thing that I need to do is just type the function. In this case is gx equal x plus 5. So I type g of x equal x plus 5 in the input area of the calculator suite of GeoGebra. So and press enter. So now GeoGebra have the value of the function, and to compute, for example, if x approaches to 1, the only that I need to do is just make a substitution x by 1. So y of 1 equals 6. Press enter. But before pressing enter, GeoGebra is already computed the value of the function. So that will be the limit at x approaches to 1 of g of x. And obviously you have the graph of the function. And you can see that when x equals 1, the value of g equals 6. You can press enter. So in this way you can compute the limit of a constant that is continuous in the value x approaches. For finding the limit of the function f of x equal x squared minus 1 over x minus 1, a function like this, if you are going to use GeoGebra, you can again type the function f of x equal x squared minus 1 over x minus 1. So define the function. For the power, use the circumflex symbol that in the case of my computer is in the key for number 6. So if you type shift number 6, so we are going to use the circumflex symbol that it will be used for typing the square, the x square. And the division key, it will be using this slash. So that's what we are going to do. Define the function. Notice that you cannot make a substitution of x equal 1 in the value of the function. So you type here 1 minus 1, there will be an indetermination, there will be a 0 at the denominator. So anyway, define the function f of x equal, and because everything will be dividing x squared minus 1, so you should type this squared minus 1 in bracket. So it will be x squared. So I'm using now, at that moment I press the circumflex symbol and then type the x squared. If you want to go out of the exponent, then use the right arrow key. Now the cursor of your mouse is outside of the exponent and then type minus 1. Go outside of the brackets, so you can use again the right arrow symbol outside and then the slash for division. If you press slash, now GeoGebra immediately is ready for typing the denominator of this expression. Notice that GeoGebra is making a graph of the function x squared minus 1. We haven't finished. So let's type now the denominator x minus 1. Now we have the graph of the function x minus 1. And we notice that we cannot substitute, we cannot type f of 1 because it will be an indetermination, but GeoGebra, when made the graph, is going to make a hole in this. If you cannot see this hole, so you can see a hole, a point that is missing, and that's happening when x equal 1. So GeoGebra show you what happened in this point. If you cannot see this, because sometimes when you make the graph is in such a way that you cannot see the hole that is missing, the missing point in the graph. You can go here to setting, in case that in this case I am seeing the hole, but if I don't see this missing point, what I'm going to do is just zoom to fit. So go to setting again, go to setting. For example, in this moment I don't think what is the missing point, but if I want to see the missing point, go to setting and zoom to fit, and just click close to the point when x equal 1, and you see here removable discontinuity. So this is a removable discontinuity. So there is a discontinuity in the graph, and that happens when x approaches to 1, the value of f of x approaches to 2. So in this way, you can compute the, the limit of a function that have a discontinuity just in one point. And that's happened when you make a substitution and you find that the substitution will give you a 0 at the numerator and a 0 at the denominator. In most of these cases, you are going to find that there will be a removable discontinuity, and this removable discontinuity can be found in Geogebra. Just making the graph of the function and noticing a hole. In case that you don't see the hole, remember, zoom to fit, click in zoom to fit, and click close to the point in case that they don't show you the removable discontinuity that we are looking for. Okay, so that's the way that you can work in Geogebra for this type of problems.